Is the mic on now? Okay, there it is. I think it's working now. Default. All right. Hello. Sorry. Okay. That's good. I've got this on. What are we doing today? So on today's on today's docket today, right now, going to be working on a few things. First, I'm going to fix this unit because it has like a weird, I'll show you. So this is like a unit that's having thermistor issues, right? So that's one of the things I'm going to work on. Well, sometimes it comes, sometimes it goes. And then, let's see, maybe if I switch it over. I was getting E1 problems before, but we'll check out the Pro because I think I crushed the wire in there. So, oh yeah, that's not supposed to happen. The temperatures are looking good. We'll see, it goes to 66 and it switches to 180. So we're having some issues with that. So I'm gonna show you how you change out your probe real fast. I got an extra one here that I found. I probably need to order more along with some bulbs. So I'll be working on that for the most part. And then a ton of the other stuff today is gonna be a lot of like ESP32. So what's going on with ESP32? Well, basically, I don't know if I can give you the long version, the nerdy version, but so with ESP32, the only reason why we were using the Arduino Nanos and the Atmega chip series, because basically the 5-volt out. The logic on the main board to the V1 uses 3.3 V logic, and as far as we know, we needed a logic shift whatever device to shift from like the logic from 3-volt to 5-volt to work with this. So a lot of the other ESP32s, like I know this one I've tried out. Where is it? We tried out with these ones, the S3s, and I got a big boy one. Where is it? I got a bigger one that one of the wider ESP32s. That's pretty popular. That was another one that wasn't working. So when it came down to that, it was, we can't use it unless we put a logic level shifter, and it kind of just made things more complicated than it had to be, because we were really just communicating between, communicating from Artisan to the board, and we didn't feel like we really needed a ESP32 for the project. But now that we're adding certain things and doing like maybe a little PID implementation for some people that are interested, and just maybe higher sampling rate, adding Bluetooth connection for the high beam. We implemented the ESP32 S3 with that, and for some reason that was communicating with it, but not with Artisan, so we couldn't figure out that. And then recently we found out the Arduino Nano ESP32 actually, it connects directly to the roaster without a logic level shift or whatever called. I need to figure out the name. They actually do connect to the computer, so now you can literally get one unit to do both if you program it right, to either connect to USB and then read out the TC4 protocol that way, or over BLE or Bluetooth Low Energy using this. So I'm still wanting to test this more before I send it out. I feel like I might be hurting something because it's supposed to be 3.3 volts and this is getting 5-volt logic. I don't know if maybe there's something I'm missing, or this will be a detriment to this unit. So I guess we're gonna find out. But at this time, I'm still want to test this out before I like recommend everyone going out there and buying all the Arduino Nano ESP32s, and they cost quite a lot more. This is like a $25 unit. They're well built, and you get it from Arduino, so you get to support them. They're just more expensive than going on AliExpress and getting one of these for $2 or $3, or buy 5 for 20, or 10 for some places. Like you get them for $1 each, right? So I don't want to recommend this. Everyone buy $25 Arduino Nano, and all of a sudden it pops on you, and it's like, what the hell, man? 25 bucks. But you can get these on Amazon, and if you wanted to, just change the pins out, and you could actually have this connect to high beam, as long as you connect to the same two data 2 and 3s and ground. You'd have to get another. Well, I guess you wouldn't. You would just need to connect here. Well, now this has to connect to the roaster. So yeah, you still would need a USB cable, but then you would need you would just unplug that. It would be just this box hanging out. But you know, either get one of these or one of these, and this is like basically almost the same size. It does the same job. You just slap it on, and that's why we like the S3. Also, the S3 you use the plug for the same thing. You plug it right in and it works. And with the S3 still, you can still add things onto it. Like I added a thermocouple onto it, so a lot of things you still can do. Manageable. It's pretty manageable. I mean, I had to add a little wire soldering there, but that's just for testing purposes. I do want to make 3D printed like case to have little compartments you could connect to, and it all kind of connects together in there. But that'll be another project for another day. There's still a lot going on. We're still waiting for the V2s to come to my house. I have 30 coming to my house, and I'm waiting for those to come in. And then what other else stuff we got? And then just basic implementation of this stuff. There's a lot of things I'm kind of working on. Some things I need to handle. Let me just get this camera going. Did I plug this the right one in? There we go, webcam. Let me get my mug on here. Osmo. There we go. Oh, switch this over. Okay, so yeah, so real quick, I'm just gonna refurb this unit. It shouldn't take too long. It shouldn't take too long at all. It's just really just replacing wires and opening up the back case, which you can do pretty quickly. It's just 20 screws. It's pretty wild that there's that many screws that you have to take off. You need like 4 just to keep the back on, but that's neither here nor there. Yeah. Okay, so check my face, bud. There we go. All right. So let's start this. Let me get this up a little higher. No. Oh. There we go. All right. All right. Let's see. All right. So let's open this unit up. And we should play music because I don't want to hear me breathe the whole time, right? We'll do just a simple lo-fi hip-hop. Alright, let's open this up. So I've got my handy screw. So remember, this is just the fascia. Or I guess they're called fascias? I don't know what they're called. But there's 4 screws that attach to them, so you just want to pull those out. And you want to pull this one out. And then I'm going to pull this one out. Front cover comes off just like that, okay? Put those 4 screws off. Next one you want to do is this front panel. Find the right size one. It's too big. We'll try this. You know what I should do? Actually, I should pull the back panel out first and unplug this thing. those screws are still there. All right. Now it's the gauntlet process of pulling all these stupid little screws out. So there's 20. And I'll go through each one. You know, if you do open yours up a lot, just put 4 screws in. Makes life easier. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I'm gonna count it out. I always get mad because I always have to take 20 screws off, and I'm always like, God, why am I doing this? All right, pulling those two out. So right now, filters, or the what's it called? The filter, the NPC probe is shooting out numbers that aren't right. So we're gonna replace it. I know I crushed it, so that's why I know I need to replace it. But usually the common thing when you see like an E1 error, that usually means either your NTC thermistor has popped or you have a broken board. And those are usually the 2 indications. So either replace the thermistor for, like, you know, it's pretty cheap. Well, it's not cheap. I think it's like $10 if you order it from AliExpress through iTop. Or you might have to replace the board, which is like $25. And right now, the only place you can get the boards at are through the vendors, through iTop. iTop would be the biggest person to purchase a replacement board for, I think, for like $2 altogether. Which I guess, you know, it's not too bad. Towards the edge. I think that's it. Yep, that's it. So pull this. What you can, quick way to like not have to get pissed off with this thing, because it'll tug and it'll snag and it'll make everything harder. You can just pop that out just like that. Just hold here, and I usually put a thumb here and I just pop that sucker out. So yeah, hold it here, thumb in there, and I just go, and it'll usually just come right off. You want to pull this out over this way and then remove that, and now you can freely move that cord back and forth without having to be annoyed. These 2 small screws, though, that's the electronics coffin box, so we'll move that out the way. Pop that out. Snake this over here. And put that to the side. Open that thing up. So now I'm looking for the probe wire. Let me show you the picture of where the probe wiring is. Skywiki.coffee. That's the website that I use. I upload everything. I try my best not to put ads on it or anything like that, because it's kind of lame. It's like when you get a recipe and it's like, I just want to look at this recipe real quick, and then they tell you like their time in Tuscany. It's like, oh dude, I just wanted the spaghetti recipe. That's exactly why I wanted not to deal with my website, with the website. Let's hide this. Main board. Okay. Right. So right here, let's pop open that. So this is kind of what the board is. So probe, fan, exhaust fan, drum. Drum, just mind polarity. I think I'll spin the different direction. So if it doesn't spin, I think our drum spin clockwise. So if it doesn't spin clockwise and you're looking at it, you can reverse the polarity so it can spin counterclockwise, I believe. But we'll see. So don't mess with that unless like something gets all futzed up. But so the biggest one is also exhaust fan. Exhaust fan in the back. I get a lot of people where the fan kind of blows air back into the chamber, and people are like, "What the hell's going on? Like I'm not getting any smoke out. All the smoke's in the chamber, and it's coming out the front. It's basically that the you know, it's pulling air back in. So you would just flip those wires over, either at the connector or at this connector or at the crappy little fan that they have. And then probe. This is the probe we're going to be changing. So, and you'll say NTC. So, NTC probe. That's how we know which that one is. All right. So let's go ahead. So I pulled this out. I'm going to look for the first one. I'm going to pop this sucker out. I'm trying my best not to take this whole thing out, but I'll just take it out. Why not? There we go. I usually, when I pull the board out, either grab from like these two here or the big old heat sink. This is look how chunky it was. Look how. Sorry, let me just show you real quick. So this is with the original board. That was the heat sink. Now they got a big boy heat sink. But it doesn't mean a damn if it doesn't have any ventilation. I realized I didn't put a fan on this either, so I'll probably put a fan on this today too. If I have time. So here, pull this little connector out. Alright, pulled that part out, so now I'm going to just pull this right through here. The connector's kind of thick though. Oh. I gotta cut this part out. In the back there is a little zip tie that they put on there to keep all the live wires together, make them look neat. Technically, I guess we're not supposed to be back there. Okay, little zip tie there. Move the fat wire around. I gotta fat finger it. got that out, so I'll leave that board hanging like this. Next thing we'll do, flip it around. I'm gonna leave it hanging right there because I'm gonna put the connectors back in, but I guess, you know, should be good and not make a mess and leave it. So I'm gonna maybe put the board back. Put the board back, there we go. Okay, I'm gonna flip this around. Let's take the front part out. I think these are all 4mm, 4mm hexes. So, oh, you know it's not. My bad. Lights you. I'm using an S2H3. But if I were to use my... Oh no, I don't wish to remove monitor. But if I were to use like one of these, it'd be like a 3mm. But I don't waste my time. I'm gonna pull this out. And then I'll pop this out. So. I probably should have left one on top to hang on, but you know, whatever. Alright. So grab this whole unit like this. Just pull it back. This right here, this is where the probe sticks out, okay? I always gotta lose my Phillips, the small Phillips. I always need the small Phillips. Too many units. There it is. You want to use the appropriate size Phillips screwdriver because these things right here, they tend to like, that's even a little too small. They tend to like round off if you do it too hard. So I think there's 3 screws. This thing's still hot as hell because I turned it on. Well, let's open it up anyways. I don't think, maybe this is the one I didn't crimp the wire on. We'll find out. So now you take this screw out. There's 3 screws that hold the panel in, okay? 1, 2, and I think this one 3. Two and 3. Okay. And then this will pull off like so. I said like so. Super easy to pull off, right? Okay, then you got to pull this thing off right here. Just like that. We'll keep that here. Let's just not lose the screw. Let's take that out and put it to the side. All right, so this thing right here, it's our probe. So we'll pull that probe out, and it's just connected to this little, there's a little bracket. Where is it? Here. So this NTC probe has this little bracket right on there. It's riveted in, and you really can't find these anywhere. You have to special order them, and they don't tell you what kind of NTC probe it is. Like, you know, if it's like 100K, 250K NTC probe. So they just kind of don't tell you, and they expect you to buy it from them. Or you can be like me. I've ordered a bunch of RTDs with this exact same design, and I plan on with one of mine to put the Max 31865 to do all my sampling with RTD. Probably do some oversampling, real nerd stuff. There it is. Yeah, this is the one I messed up on the crimp. Okay, so good. Not the crimp, I crimped the wire really bad when I installed it. And this is kind of just held in by this 3mm nut with this little 3mm. There it goes. This is just like a little 3. I'm actually going to replace this. I'm going to replace it with a hex because look how rounded it is. It's kind of dumb. I'm going to replace that with the little hex one. I got a bunch of them from 3D printing, so if you notice you have any errors, mine has this really bad crimp in it that kind of went down to the wire, so that's probably why it's giving me all these weird numbers. All right. Okay. I was really worried I was going to have to pull the side panel off to get to this thing, but it looks like we got lucky and I was able to pull it out at the same time. You just want this little protective sheath to cover the wire in case it gets all melty. I think the original one's got a little melty because it got hot at the sides, so they actually added like this little fiberglass sleeve to kind of cool it, to protect it from the heat. And they're a lot thicker than they were before. Like if we compare it to, this one came probably when the V1 just came out. There's no like extra black sleeve to go along with it, and then there's no the fiberglass sleeve to continue protecting it. So make sure to reinstall this one back in. So I'm gonna pull this out. We also made that wire thicker, so I can't pull it out like I used to. So we're gonna have to go a new way. Not really new, but we're gonna pull the drum out. The drum is held by 3 little, I think, M8s. So I got one of these things, long handle ones, if you ever want to buy a good tool to take your drum out. I highly recommend one of these T-handles. I want to say they're M8s. I'll have to get back to you on that. One. I'm just going to pull the drum out so I can have access to the little plug. To the little JST plug. They're called JST something. There's a certain name for them. But they're like little JST plug. Or JST connector things. All I know is they're not microfits. So, JST. This will help you when you gotta like line the wire back through. So we're gonna take the drum out. It pops right off. Make sure everything is there. Okay, that's the inside of the drum. Nothing fancy. Try to loosen this up to get you closer. That's the drum. Very simple design, but it works really well, I think. Don't need super sophisticated. Right, next thing to go is... Oh, I'm dumb. I forgot that there's a sheath over here. Duh. Well, at least I showed you how to take the drum out. I thought there was a exposed part here. I can kind of fidget my way in there and kind of loosen this thing up, but no, there's no. I think it's completely covered. Well, at least I should have showed you how to take the drum off. Thought I could like wiggle something out through here, this little hole, but that didn't work out too well. So these ones at the side panels, they're a little bit smaller, and they're stubby. They call them stubby, and there's like 6 of them. You drill out the side to pull the side out. We're taking the whole thing off today. I really thought there was a little access port here. I must have not been thinking. Are we back? Did we miss something? I think we're back. Okay, good. I said I lost connection for a quick second. I think these are the last 2 screws. This screw right here holds this little black thing that kind of like protects the wires from getting cut. I see why it's a pain in the ass to change this probe. Fuck, there's ones on the bottom too. Oh my god. Alright. You got these ones. I gotta remember how to start putting these things. These are stubby too. The side ones are stubby, the bottom ones are stubby. I'm probably crushing the board in the back. We'll just pull this back a little bit more. Or I could just use this. There's nothing graceful about this install. side of the panel pulled off. I'll bring this back down. Right there, and you just want to access the side panel, right? So I'm trying to take the least amount of screws off. So here, we need a little depanner device. So I got this thing it's called the Microfit depainting tool, which is a fancy paper clip. So if you have a flattened paper clip or something small that you could fit into these little holes, that works really well. I have this, but don't buy this, because this is the stupidest thing to purchase, because it's literally just it's like a super small flathead. So maybe even just get like a really small flathead. But what you want to do is just try to depin this. I want to reuse this connector, so I'm trying to be nice. But I could have just cut it off. But then, you guys probably don't have all these connectors just laying around from 3D printing projects. So what you're trying to do is just bend that down, maybe bend this little clip down right here. And there's a little clip right here. It kind of, when you push it in and you try to pull it out, it gets stuck and it wedges itself in there. So yeah, you just need something real flat to go in there to push it down. And I usually lift the plastic up so I could just pull it out. So push down. And then pull out. Just like that. Now I can pull it out like there. Alright, let's go find the probe. Alright, here's the probe. That's giving us problems. There's the issue right there. I jammed it against the wall of this unit and it kind of squished the wires together, giving really weird really weird temperatures. Oh, I thought they had some kind of fancy sheathing. It's just heat shrink. I didn't realize that. I got a bunch of heat shrink. When I say fancy wiring, I mean there's wires that come like on certain 3D printers. They have like wires that are enclosed in like fiberglass to protect it from heat. So if that's the case, I'm just going to go ahead and shove those in there. Because I don't think we needed the whole length of the wire. And shove that in there. We'll just go down the line. You can buy big wide things of these, but they usually cut them up when you buy them on like Ali. I'm gonna cover that part right there. So a little thing, I'm just gonna give that a little covering, give a little protection, right? Time is it? 11:02. All right, gotta speed this up. I thought this was gonna be a quick change, but I guess it's not. Let me get my little heating gun. it is. Got there's some wire in there now, okay? Melty. Ooh, heat gun hit. Heat gun's hot. The back's hot. Alright. Alright, let's back this up. Let's find that probe. Now, I want to go in the shadow of the beam right here. Alright, so now I'm just going to grab a little, and what size did they use? Here's the original M3 they used. I'm going to just find something similar to it, but in hex, because it's better. It's more better. Really in there. Nope. I'm not gonna mess with that. I'm just gonna grab another M3 washer over here. Okay, all right, so side grade. I just don't like the Phillips because it rounds out. I'd rather just have like a nice little hex that will work just the same, but it won't round out as bad. Because the worst is like when you round it out and then it's like you gotta like destroy it half just to get the stupid thing off. The probe. And it's flatter. Good, that's all tightened in. The probe's right there. Right, so put this in here. Oh, I almost forgot a thing. Okay, all right. So when you put these clips back in, or these little JST pins back in, you just want to open that pin up a little bit. Don't go hog wild. Put on any side, it doesn't matter. There's no plus or minus with these probes. Just want to open them up just a little bit, but you don't want to go too far where you bend the metal, then you can't like put it back in place. Good. Little tug test. Tug, tug, tug. And you want to, now you're pretty much bringing this all back to this little channel, and there's like a hole in the back. So let's get this out the way. Come back. I could make it this easier if I just pull this panel off, but I'm being lazy. Let's pull this wire in more. Get that away. So, see that little hole in there? You just want to guide that in through here, because that's where it's going to go through at the controller. All right, now we put the screws back on.
chaff in the nose. I think that one's there. We'll find out. We always can pull them off. I want to say that these two bolts are there. So that's 1, 2, 3, 4, 5, 6. And that should be for... Yeah, okay. We could put the bottom bolts on later. Let's put the front piece back in. All right. So what you want to do, be careful with this. This is kind of, they use like a little bit of adhesive here to get this stuck on there, but you don't want to like rip it off, because if you rip it off, then it's kind of a bitch to get back in, and you have to use some kind of weird adhesive that I don't know what they use. Also, if you ever had one overheat, these boots will melt over time. So they don't have replacement parts for it, but I do have a way of making one out of silicone RTV. So I put the files online. So if you ever like were to melt yours and you don't want to buy one, you can have someone 3D print you out a mold, then you just fill it up with red RTV and you're good to go. Don't have to worry about that. So line this up here. So the boot will go on this side, trier goes on that side. This goes in first. That just kind of chills out there. This I got to put back together. And we'll screw that back in. Just like that. Screw this back in. This is just like a little plastic holder to hold down the wires. Oh, I'm not covering it, sorry. There. So tighten that down so the wires can kind of come straight out like that. All right, we got that back in, which you can do. Oop. And of course, got to put these 3 screws back in, okay? So there's 3 little metal screws. I wish I could change these to like the hexes, but these are tapped, so you got to tap them into the plastic. I'll have to do an AliExpress search to see if I can ever replace it, but for now these will do. I'll put these back in. Oh, that one came out. I gotta put it back in. close. So this metal piece right here will trap the little pins over there at the side. Little hinges, I should say. So 1, 2, third one, last one right there. And that's just to secure this panel onto there. And just put it snug, just put it hand tight. You don't need to like, you know, mash it in there because you're gonna like ruin the plastic that holds it in. Then you have to like get a rig away to have it keep in there. So now let's do this. I didn't do this and I really fucked up the wire that way. So push the wires in like that. There we go. So first you gotta put the drum back in, Lloyd. Alright, we're gonna put this drum back in. This is my elaborate way of showing you how to put the drum in and out. Take the drum in and out. There's only one way you can put the drum in. Because it's a D shape. So that kind of tells you like how to put the drum in. If I could turn the light on. You really want to fit it in there. Fuck, that hurt. Really want to make sure it fits in there, like it's in the actual like D pattern or half cut pattern. I don't know what the pattern is called. Because if it's off by a little bit, it'll actually hit the sides and will cause an E3 error, which usually means bad drum or bad drum bearings or a bad drum motor. Basically, there's with E3 errors, it's a over voltage or overcurrent, I should say, overcurrent detected. So there's a certain amount of current that it detects to that to the drum connector, and then if it's too high, it just assumes that there's a large load on there. Look, this is why it's kind of important to clean out your drum every once in a while. There is a bean that's probably been stuck there since the last roast. It's really like, you can't even like flick it off. You really gotta push it out. Every once in a while you get that stubborn beam that somehow makes its way stuck at the sides of the wall. Alright, so that's all in there. You can kind of test it out. Just don't spin it too high because you do create a current or a voltage. Ugh. You do generate like electricity when you move the drum. Alright, so this wire right here, make sure to push in nice and gently. Make sure there's no excess hanging out. Push it in through there. What you can do too is if you want to lock in your drum, and then it kind of will stay on point. It won't move that much. $24, good. Put that back in. We're gonna put all the little hexes in first, okay? So I'm gonna go top side first. Not tighten all the way, just a little bit. Just gonna go around the thing. Oh, yeah, I did put. What was the other ones? There. I'll put it on the wrong ones. So this one goes down, number one. So this one goes down. I'll just put another one in here and I'll take the other one out. Okay, so let's go over the holes again for this thing. So for the front panel holes, this one, this one, this one, this one, right next to the probe, right in here, and they should be the same, and the ones below the probe, those ones attached to just the drum wall, okay? Let's put this back in. Like I said, make sure to ease that wire into there. It's very sharp, the metal. You don't want to let it get smushed, causing errors with the readings and stuff. Just find the hole again. Tighten it in. Being held in by the by this part. That's where the drum gets held in by. Put this back in. So, speed it up a bit. Top side first. The top left. Not all the way. Bottom right. I'm gonna go here. Here. That's in tight. Two more left. I'm gonna go down to the bottom. You don't need to do it this way. I just do it because I think it centers it a little bit better, and I can make sure it fits in all the holes. So it's nice and loose at first. So then I'll tighten a bit. Tighten. Just hand tight. You don't need to make it crazy. Although I do have like a little torque wrench if you really want me to give you a torque spec, because I like that nerdy stuff. You bunch of nerds. So I just do hand tight, nothing crazy. We got the top, front, back. So now, don't forget, we got to put this back. So right here, NTC probe, right? Bring it. Make sure you bring it through the hole. Just kind of smash it in there. All right. And then you just put it right back into this board, okay? Should click a little bit. Now you can put these back in. Make sure they're aligned right. Try grabbing by the heatsink. That has the most strength. But just don't go like Don't hulk it in there. Just push it in. Make sure the wires are kind of lined up in the back. Do I have an extra fan? I guess I could show you what fan I would use. Where is it? I'm gonna leave this back open because I do want to put a fan in this one before I send it out. Heatsink fans. So this has like been the biggest thing about this unit, right? It's been this heatsink. You could tell that it's been an issue with the thyristor because it thermal runaway. In the beginning, people were always like, this unit is gonna burn down my house. Because they hit a thermal runaway. They were doing a lot of roasts. The thyristor, or the SCR, got really hot. I measured it, it gets super hot. If you have it even open to air, it gets super hot. But if you have the fan, like a heatsink on the fan, it actually cools it down dramatically. Because guess what? Heatsinks like air. They like airflow. What this case excels at is no ventilation. It is great for that, for isolating it away from maybe they're thinking they didn't want all those oils dropping in there, so they made a case so fully encased it and then won't get the oils to drip in here. It still does, but anyways, they put the fans. We put the fan like right onto the heatsink or to the side of it. Some people put it to the back. The new V2 units, they actually have fans built in where it just is like, it's like right here, built into the case. So that's kind of a nice addition. I think actually the new V1 units, they have that new back panel where it allows you to put a fan in there. They just don't put a fan on. Somebody told me that, so you know, it's kind of ghetto, but or not ghetto. It's cheap. But you know what? This roaster isn't like a Kaleido. You're not buying it because of the amazing build quality, and it doesn't have that price tag. We'll say that. That's all we'll say about the Kaleido. Great machines, but you know, for some of those that don't want to pay what, 1,500 to 2,000 for a unit, you know, for folks that you know are roasting for funsies, we're not roasting for real life, I guess. So I'm gonna leave this back open, just to show that, you know, because later I'm gonna put in a heatsink fan on this. I do it different ways. My favorite way is putting it directly on here, but if I don't have the right heatsink fan, I'll put it at the side too. The whole purpose of this thing is just to get airflow through it, right? As long as that heatsink gets airflow, it should be good to go. And if you looked at my YouTube video, I've done videos where I've shown just exactly how much it cools it off just by having that fan there. But you don't have to do it that way either. If you want to put a fan in, you can like literally find out where it is on this back panel. Just cut a bunch of holes and slap a fan on the back over here. I've seen people do it multiple ways. I kind of want to get into the one where the guy was making holes and then he slapped on like a fancy looking back case on it, like on this side. Like he drilled a bunch of holes, then he put like a fan case, but then he put like a sweet looking fan case on there. But that's time for another project. So let's go ahead and we'll double check if I did it right and make sure we're not having any major temperature issues. Come on, no E1. Perfect. All error codes come at the left side. I wonder if 180 is a set temperature. I don't know why it does that. Maybe I was wrong about it. See, it does 356. much about these panels, but I know that I did have a crimp on my wire from when I installed it. I just don't want to risk it messing up. All right. So there, I'm gonna leave this alone. I'm gonna come back to it later, but let's go ahead and we're gonna talk about ESP32. For all those folks who want to put an ESP32 in. So I'm gonna assume that you're super into high beam and you wanna, you know, play with this new app. So let's go ahead. Let me change the text box here. ESP32. Varum. I think that's what it's called. Varum. Let's close this off. So people been getting into wanting to have high beam on there, which is like this new app that we kind of help get Skywalker on. A lot of people in the community, you know, they wanted something other than Artisan. Artisan isn't bad. I think Artisan is great, but you know, people like they'll say, "Oh, it looks a little dated," which yeah, whatever. It does, but it controls it and does, you know, all the fancy things you need to do to monitor and data log your roast, right? High beam does the same thing, but just user friendly. So, and it does it over Bluetooth. So the reason why we really got into it because we wanted a way to connect the roaster via Bluetooth to different tablets, so you have a different avenue of controlling it. Because you're probably well aware that I am not a fan of this. I usually like this for diagnostics and showing me the error codes, and that's about it. If I could have it my way, I would never want to use this again in my life. But I just don't like touch. I just don't like the little crappy touch feeling. I'd rather have just like a touch screen, like on a phone, or physical buttons is my biggest thing. I love physical buttons, so I prefer that. And this is all preference issue, so don't. I know some people love this. They're, oh, this is the best thing in the world. Oh my god, it's okay. I'm not a fan, so you know. But if you do like it and you're roasting with this, more power to you. But if you want to like log things and do things like that, you know, putting Artisan on it might not be a bad idea, or using high beam just because you has a phone that can log it, and then you can share your roast, and you can track your roast, and you do all sorts of things with high beam. You could do all sorts of those things on Artisan too. It's just a little bit more configuration, a little bit harder to do. So that's why we're kind of into the high beam hype right now. But ESP32's biggest issue is needing a logic level converter to, you know, send out the go from 3V to 5.5 logic. But we did find, I did find that, oh no, somebody in the Discord found out that let me show you this one, that this one, the Nano ESP32 version, it works. Like, it's ESP32, dual core, and it works to run high beam, and it works to run Artisan. So, you know, maybe one night of coding I could probably get either or to work on just this one unit. So you could either plug into it to be a BLE and connect it to high beam app, or you can do direct serial USB and do it direct to Artisan. Yeah, I would just have to make another section, like a void command whatever thing when I'm coding, and then just put like output straight the USB, all the TC4 protocol. That's really what it is. That's all this thing is doing, is literally just getting the read command, sending out these numbers to it. So it goes read, it does like, I think what, 0 environmental temperature, beam temperature, I think it goes OT1 is heat, OT2 is exhaust fan, and everything else is pretty much by command via over serial. So yeah, so let's check it out. So I'm gonna plug this in. Let me move this out of the way. That's plugged in. plug this ESP32 into here. And then I'm going to plug this through here. That's all plugged in. Alright. I'm going to put the second screen on. I'm going to close the screen. We don't need to see this anymore. Pixel off. Window capture on. Window capture? Or display capture? That works. Okay. So let me open up Artisan. Okay. Alright, we have Artisan opened up, so we'll do the usual thing. We'll do load recent settings, then we'll load the basic SkiTop Artisan setting, right? Config port. And then let's figure out what COM it is. So I'll do the old unplug it. Which one's out of there? 23 is out, so let's plug it back in. And then close it back up and then put it to 23, hit open. It works. It's the ESP32 and it works. Now, you can't do this with the S3. This thing, because of the thing I was explaining about the 3.3 logic. But for this Arduino one, for some reason, it works. I don't know. I haven't figured out why, but it works. And it's been kind of nice. So I'm gonna be working on this a little bit more. Maybe there's a setting I put in, or I don't know. They're doing something different with this board. With this ESP32 nano board. There's something different about it. And turn this off. Okay. So next thing we're gonna do is let's show the code. I'm gonna open up Arduino IDE. Arduino IDE. Okay. So there's been a lot of questions about, hey, I want this certain ESP32 to work with my high beam. I got the ESP32 room or W room. I got the big thick one with more GPIO pins, and it's a lot bigger. Is this gonna work? It should work. Let's open up Ski Bean. Oh, this is adding PID. We'll look at that whenever I get more testing on it. Oh, you want to do that real quick? Hamster rays? You want to see how that is? It's really fast. Yeah, let's do that. So here we go. We'll go to our fancy schmancy website. So I'm gonna go SkiTop Roaster, skywiki.coffee, high beam firmware install. So you got your S3, okay. All right. So what you want to do? I'll close all this stuff out. Let's turn this off. Let's focus for a quick second. All right. So got the instructions out. So basically, go to ESP32S. That's the link to Amazon. There's no affiliate links because I don't need affiliate links. So download the binary link file. And that brings you here. And you could just hit like download raw file, right? Okay, so download the raw file. Next thing you got to do is just go down the steps. So download the raw file, click on the SkiBee link, then go to ESP Home Web and this is a click on that link. So let's grab this thing. We'll use this. One big thing people get hung up on is, it's not showing up. So you got to hit the boot button and then plug it in. So you got to hold the boot button, plug that in. When you do get them new though, they plug right in and they should work right away. But sometimes you need to plug the boot button in, plug that in. And one way you can know if it works is you look connect and you'll see something called USB JTAG serial debug unit. And I think it's refreshes, so you can unplug it. It's away, right? So you can technically, if you want to see if it's working, not technically, you can. You just hit connect. This is kind of open. I want you to hit boot, hold the boot button, plug it in. See, USB JTAG's in there. So now you just hit that, hit connect, install. And install existing, whatever. You download the bin file, so that should be in downloads. I already done this like 3 times. So whatever, just find the ski bin file. Just click on that, and then choose install, and just wait. It will take 2 minutes. So if you're in a rush, just wait a few minutes. Some people are like, it didn't happen in like a minute. Just gotta wait a little bit. It's working. Failed to open. Failed to execute open on serial port. Is this on Chrome? Google Chrome? Oh. Okay. Failed to execute open on serial port. I haven't had that one happen to me yet. Oh, but on Linux? Oh. Try it on their Windows box. I'm not a Linux pro. I use Linux Mint. Yeah, that's the kind of guy I am. I use Linux Mint. I'm not like a great Linux user, although I do like all the commands you could do in terminal. Yeah, I usually just use Windows. But try that. I gotta figure out, maybe I'll get Windows. I'll get Linux Mint. I'll put that on my ThinkPad again, and then I'll try it out. Do I have the ThinkPad that I need? I think I do. B button is the boot button. You just got to hold the button. Hold that button, and then you plug it in. And it should enter into the bootloader mode or whatever. I haven't tried installing in Linux. I haven't tried installing in Mac either. Through Mac. I thought it would work the same. Maybe not. Maybe you could do like either through VS Code. Oh no, I don't know if they could do through VS Code through Linux. What would the Linux equivalent be? Does Linux have Arduino IDE? Because if Linux has Arduino IDE, you could do it by the sketch. It's just a few more things you got to do to get it going on Sketch. But yeah, B button is the boot button. Also, yeah, like I was saying, if you wanted to do other Arduino units, let's go look at the code. We'll download it. Ski bean. Okay. So I'll do this one part. So, all All right, let's say that you open Arduino IDE. You're gonna copy. Let's copy all this stuff. Copy the raw file, and then let's go put it in the IDE. Good. You know, just open a new screen. You can copy and paste it in there. We'll go all the way up, all the way up, all the way up. All right, here you go. Those are length. Okay. 16 and 17 for the S3. Those are special to this unit because 16 and 17 are within the they go through the USB port, which is why it made this such a nice little feature to have, because we could transmit stuff through the USB port instead of having to use one of these other GPIO ports. But not all ESP32s have that option. The W room ones, the other ESP32 variants, they usually have other pins you can use. There's a plethora of pins you can use. Let's just say you'll use 16 and 17. Do I have one here? Let me grab one. I'm gonna show you the pins real quick. Pixel. Okay, so there are different variants, right? I'm already holding, I got like 4 in this one picture. ESP32s, S3s, this is what? W room 32, and this is same thing, 32D. Looks like the D's a little bit wider. I don't know. There's pin differences for sure, right? That's the beauty of ESP32. There's different types and different kinds. I know a lot of people are using these two. They have them around, and you know, a lot of people have like a bunch of these lying around. They're like $5 a pop. You get them on AliExpress or stuff like that. So with this one, you just find a pin number. You could go online and check out what pin numbers would work. I've been constantly using 16 and 17 for those for the transmission pins. So, oh, not 16 and 17. Yeah, 16 and 17. I've been using those usually for the transmission pins. Oh, S2 and the S3 uses 1920. My bad. Okay. So 16 and 17 uses the oh shoot, my wife's calling. But 16 and 17 usually uses the I usually use that for when I connect it to these big one modules. And then the S3 uses pins 19 and 20, which are special because those 19 and 20 pins, they connect to here, to the USB. So that's where you're able to connect it in. And then for this one, I actually, for Arduino ESP32, I use pin 2 and 3, kind of like what we used to do with Arduino Nanos. So what you do, let's go look at the code. You're going to find a section. It's called TX pin 16, TX pin 17. Just look for TX pin. It'll either say 1920 or 1617. These are the GPIO pins you want to replace. So you say, hey, I want my 1617 is busted. I want to use another one. Like, oh, let's say I want to use, I don't know, 12 and 14 or something. You could just switch it out to 12 and 14. Okay, so 12 and 14. My keyboard's being stupid. And you just switch that to 12 or 14. But, you know, I like to keep it just the same and just recommend people do 16, 17. Because at least I know I picked those two. And those are kind of the common ones. Not common. They're common to this other TC4 project connecting to the M2 Kaleido. So you can replace those two numbers. They'll go to these different pins and just use those as transmission pins and RX pin. You know, if it doesn't work, you could switch those pins around because you might have put like the transmission pin on the wrong one. So if that doesn't work, feel free to switch those numbers until you get them to work. Usually you'll know it works when you'll see temperature come out. Okay. And that's for, that's when you want to use for the ESP32. It's kind of the same thing if you're using a Nano. And surprisingly, the Nano code will work on this. Like, this code, this other code I used, the original JMOR Sky Command code, it actually works on this one too. So you can literally get one of these, install it, put Artisan on there. You can wait until we put in like the code where it could do both high beam and Artisan, or high beam and Artisan. That will be another update code coming up whenever I have time. And that's really all you got to do. And then you would install it like normal. So you would hit, upload. You upload the sketch, does all the stuff, and then it'll tell you it's ready to go when it's all finished uploading. And that's pretty much it if you want to use it for different other ESP32s. You don't have to use the ones we're using. The code should work for all the ESP32s that have BLE. There's some versions of ESP32s that only have Wi-Fi, and that won't work for that one. Like I think the coprocessor I think the ESP32 is a coprocessor on the Arduino R4 or Uno or something like that, so it won't work on that. Basically, it won't work. The high beam code won't work with anything that doesn't have a BLE on it for now. For this instance, but that's because I put most of my money on the BLE code, because now the BLE code works for iOS and Android, so more people could play. But if it were up to me, I'd do Bluetooth, because I was like a lot simpler to set up in terms of the code. It wasn't as a daunting task to get everything to work together with this Nordic UUID stuff. But that's neither here nor there. You don't have to worry about that. Yeah, that's how I'm going to put the fan in this later, and I'm going to ship these out to a few folks. I'm actually going to ship out to one other person. I'm kind of excited to see when they get it and see what they think about it. And we'll probably have some kind of like giveaway of it too. So if you're interested, if you're seeing this and you're working on it and you have a friend that might be interested in getting one, we might have a little bit giveaway. But still, I'm still selling these for about $340 now if you want high beam on it. $340 for a refurbished unit. It takes time. I'm not trying to do this for profit. I'm just trying to get these roasters out there and out of e-waste, and keep it friendly to the community, because I feel like everyone should roast and not have to spend $2,000 on an amazing unit when you can get a decent unit like a Skywalker and be able to roast at home. Because the bridge between different roast costs is crazy. Like, to get a decent roaster with all the artisan stuff to track and log, for some reason it skyrockets to like 1,500. Or you could buy one of these for like $330 from me, and that's already has artisan on there. Or you could buy for like $500 and spend extra $10 to get artisan on there too. We provide you, all the instructions on how to do it. Yeah, that's kind of how I want the community set up. Just keep everything free, everything open. Because Artisan Scope is open source, right? I think it's open source, or at least open to the public. We should kind of, it'd be kind of nice to keep that going. What I don't want to do is like see people out there charging $50 for one of these units, and they literally just put a code that is open to the public out for free. And that's one of my biggest concerns is that happening. Because not only are they profiting off of other people's work, they're like, it's kind of a dick move. So tell me if you ever see someone trying to sell one of these 3D printed boxes with a breakout board for like $100, and contact me and I'll find someone who can make it for you for $30. I don't think anyone should be paying that premium. But at the same time, I don't want you thinking like those people spending their money soldering and everything like that shouldn't get paid like a little bit more than what it costs at parts. But I'll leave that up to you. But just tell me if anyone starts charging $200 for a box full of open source stuff. Because or the community is striving to make everything simple, like this ESP32 that you just plug in the back. Did it go great? Okay, good. Hopefully that works for you. The code is still a little janky, so you might have to unplug it and plug it back in to get it to work. Oh, but I better go. I gotta go pick up my cat. So